I'm Patrick. Most of people know me from starting the DevOps days. I recently, like 2 weeks ago, joined SNCC, which I'm happy to be there. So that means I can go to conferences like this and kind of speak more. So it's really nice from them. But today we're talking about how is your CI or your build secure, and it's all about it is about like, did you build the build you wanted? And I'll explain what that means further. It's actually a story about trust. And it's like, it's like the kids, when they say they're going to do something, you think, teenagers, never trust them. Like your mother learned you not to trust strangers. But what we do all day is actually trust strangers when we do working computers. This is quite a technical talk. Like this is going to be not like coding, but like some commands and stuff that I'm showing. So if you want to leave the room, that's fine. This is research that I did. I don't know everything that's in there, so bear with me. But I want to give you like an overview of the things that I came across doing that research. So security, that means that I can talk like days or weeks or months on it, so we need to kind of narrow down the scope on what we're talking about. So we're just going to talk about delivering things to prod, so not while being in prod or doing that. I'm not going to do scare tactics, because a lot of the security talks about like, things that couldn't go wrong. I don't care. I just look at like what's possible, what's not possible. I'm not going to talk like modifying hardware in any way. This is not the scope of this topic. It's all about like software or things that go in that perspective. I'm not going to do like a nationwide attack, like putting a chip in the Apple computers or something like that. I'm not about like not extorting people, like putting pressure on people to like change things. Like this is not the talk. And I'm not talking about like having physical access in a way that you get new physical access in ways that you don't want them to be happening. I'm not talking about key management. It's important to have like secure keys and keep multi-factor authentication and do stuff like that. But again, like scope going down there as well. And I'm not talking about like any hardening or like securing servers, laptops, and so on. So, we narrowed it down. We can probably still talk for a week, but that's the best I could do. We're mainly focusing on how we can tamper things during the things that happen inside of the build. So anything from changes that we didn't want to have happening. For some of you that are familiar with promise theory, part of a promise theory is really hard about trusting people and trusting others. But one of the important parts is that the trust is about verifying others. So you end up being responsible. Even if somebody else changes something, it's up to you to make sure that you can deal with the situation if somebody does that. So a lot of it will be about like the verification that we can do. So think about the first step. A pristine laptop, you bought it in the shop. So yeah, no hardware hacks, no changing of the software and so on. What's on that machine? The new Macs can do like a secure boot. They have like the certificate authorities in there. You can do like the secure laptop, encrypt the hard disk and so on. But it's just kind of like the starting point of this talk. The laptop of the first developer, we kind of have trusted everything around it, and we start from this point. So a lot of people think that developing is still about like writing code, but I think more and more it's just like assembling libraries. Definitely if you're like in Node.js, they have like for a print line, they have like a library or something like that. It's just pushing everything together. And we have like a lot of libraries. I take the example of Homebrew, like coming from a Mac, NPM, because I'm gonna take like some Node, some Docker, and the App Store because stuff we kind of download from. But first, one of the important things before trusting anything is about talking about TLS or SSL or certificates in a way. Because the first thing this will do is like reach out, do like an HTTPS call. If you're lucky, it's not HTTP. And then it will fetch something from the network that we don't know. There's many things that can go wrong. This is kind of the threat modeling for SSL. We're going to focus on the lack of validation, the weakness of the protocols that we're doing. We don't care about that. We just hope that it's secure. When we get the laptop, we go out. We don't verify that, but there's a lot of things that we can trust and verify there. The CAs, we kind of trust them, but if you have like an older laptop, there might have like a new CA, you're kind of already taking the trust. Just by having that laptop, you kind of taking a trust in there. And then there's the attacks on ciphers and stuff like that we want to go against it. This is an example of Node. There are ways, if you would run Node or NPM, to kind of limit the ciphers that you actually want them to use. So they're pretty wide open by default, but if you want to get a little bit more secure, you can say, like, I only trust like this ciphers and so on. Interesting enough, like curl, if a certificate is revoked, something like curl would not validate that. They would just see, well, it's still valid because it hasn't expired, and that's about it. Like, I didn't realize that was still the case. I would have hoped it would check that for me, whether there were any revocations. But apparently, we just trust curl because it's there and we use it. I think in the last couple of 2 years, Let's Encrypt has really like set a new bar. They've changed the certificates a lot more often. They put like stress on no wildcards and so on. So they pretty much automated a lot of the trust that before we had to do manually, but we're kind of improving that in a good way, I think, there. And if you want to go a step further, with now the certificate transparency, we can actually see from the CAs what certificates got requested. So if you're using like Amazon Certificate Manager or so on, you can kind of find a list of all the certificates that have been asked. So if somebody asks it from another CA server authority, you would know, and you would be able to see that. Before, you would know that it was just given to them. So you can set up webhooks to monitor your domain and kind of keep track of that stuff. And if you want to go a step further, you can limit in DNS with records to say, well, I only trust these authorities, so you cannot get any certificate from another authority, even if you are like they have like a weekend like verified by email or something like that that has been hacked. I would not allow that to happen. So again, like there's some controls we can put in, and we're getting better at it, but still, you know, the tools have to catch up on the trust. And of course, everything. The other thing that we need to trust is DNS. I don't know, is Chris here? Well, you know, it's dedicated to Chris. If you would look, like you would think like DNSSEC, yeah, that's probably what we'll be using. But okay, something fell up off the top, but Debian has it, Brew has it, Homebrew, Node.js, NPM doesn't have DNSSEC. GitHub doesn't have DNSSEC. That was a surprise to me that they didn't have that. So I couldn't verify the domain in a good way. So there's steps to be made there as well. Even curl, again, doesn't support DNSSEC. So you would expect that we were there, but it doesn't. So, you know, it kind of gets my trust wonky, like my teenagers. After a while. And then there's this, right? So we kind of explained DNS, and the first step a developer does is put this command in because they need tooling, and Apple doesn't provide a good way of getting the tooling, so we trust this. And it's like, really? But yeah, so luckily we can see what master is, master install, but still, you know, it feels a little bit bad for doing that. Node is a little bit better. We can curl it. We can check the checksums, verify it with GPG keys. It's nicely documented, so you know that's one step forward. It's still something that's kind of somewhere obscure on the website, so you kind of have to start looking for it. And again, I would hope that it would be more automated, or kind of when we do that stuff. And then I want to have Docker, so I have like Homebrew for the compilers. I have like Node for running that, and then I have like Docker. Docker, the verification there goes through Apple. So we would have to trust Apple again, that the one that got the signature for that company is actually the signature that we're verifying. Okay, it actually. On this same ticket on Stack Overflow on GitHub, there is something like this: the hash keys of the Docker binaries, and it just gives like an error page right now. Interesting that you couldn't verify it. I couldn't verify beyond this that was the binary that I was downloading from Docker. So we got like the runtimes going, but the next step is that we really want to download libraries. Right? And that's a bit tricky because there's no real verification mechanism in place. So it's like, yeah, if 10,000 people downloaded it, it's probably secure, right? So let's do this. If it has a README file, that's good. Luckily, we can go a little bit further and kind of look at vulnerability databases at least, but it's a lot of like trust. If you're unlucky, it's a library you really need, and it only has like one maintainer, one developer, and kind of, yeah. Another attack vector is that while installing packages, a lot of them will just run scripts without you asking. And you can go against it, but there's no easy way to actually verify the scripts. It will not download it, but how would you be able to look at it if you wanted to it? So it's kind of, again, you just do it. There is a way of doing it by running everything instead of on your laptop, doing that in a container. Because then it will not pollute. You can look at it, destroy it, and it doesn't do that much harm. So there have been people looking at the tooling, whatever you used to run on your laptop straight away, they would just run that in containers as a kind of limitation overdoing that. And then, of course, I don't know who remembers this, like the advertising npm install put in there. So yeah, it can kind of have like strange effects that we just trust people to do. I mentioned before vulnerability scannings on the dependency tree that we learn more about, so we can kind of run it by any of the vulnerability databases, get that code going. And we don't have to always do it ourselves. We can have like the proxy do that for us. So for example, JFrog X-Ray allows you to do the scanning, vulnerability scanning before it comes on your laptop if you use them as the repository proxy. So that's a nice way of like offloading that part to the proxy. Again, Homebrew, really say like, it's been for ages, people have asked for GPG signed anything, and they're like, we're a bunch of volunteers, we don't do that, do something else. And it's a little bit scary there. Node has a way, but that's how it's documented on the website. It's pretty complicated to do that every time again. But it's doable, kind of. So we got the code, we got like verified all the parts, and now we're just signing our commit and put it to the database. But what if somebody grabs your GPG key and kind of goes from there? I found an alternative that is called Git signatures, which allows you to kind of multi-sign the same commit, so with multiple people. So you can kind of have the more consensus way of, multiple people kind of did the same thing and verified it, so it's not the solo person. You can do it with like a pull request, but this is kind of a more a way that is more persistent in a way that you can see the signatures of the people who have put it there. And then when you put something in GitHub, you can verify their SSH keys, not just like do git push, but you can verify it as well. It's pretty well documented on the website. And then we have like our code, our libraries, we put there, we check it in the repository. There's a little bit of a different story for Docker. Docker, the trust model is based on TUF. It's the update framework, and they kind of have a way of And if you look at the different things, it's very similar to what I explained with the CA system. So you don't have like one key, you have multiple keys with different duties. So if you only compromise one key, you can kind of have the chain that you need. There's threshold signatures, like I've shown with Git. Like depending on what you're signing, you can mandate there's like 4 people signing the container, the upload, and so on. Important, the revocation of the keys. It's built into the framework. And we don't, certain keys, like the root key, we don't want to be used all the time. We want them to be safe somewhere offline so people can't have access to it. And we don't need to share keys because we can delegate the things that we want somebody else to have, and we don't have to just share the key in there. So the process is pretty similar. You kind of sign the Docker container, and then you kind of say, I trust sign this, similar to your Git request commit, and then you push that into Notary with the flag Docker content trust, and it pushed out, and you can inspect it. So far, we have our Git code, we have our kind of container checked in a repository. So that's where we are right now. But then most of the times, it leaves our laptop and it goes into a build server. And the build server, we don't know, right? Maybe if it's inside your company, but if it's on a SaaS system, who knows what they do to our code, right? So this is one of the first papers that thinks about that. Is like, what if somebody changes just 2 bytes, the effect on the compiler or stuff like that. What's interesting is that the people building the binary for Bitcoin, they use a consensus model to see whether the build was the build they wanted to have. So they would have multiple people build the same thing on their laptop, check the checksum, and if most of the people have the same checksum, then they would agree that the build with that checksum was the one they intended. So it's an example of how you can live in foreign territory and you don't care, and while building the consensus. So imagine doing that on multiple CI systems and kind of get the same real results. But of course, the one mandatory thing is that when you do a build, it gives the same binary. And sometimes you can change things. I don't know if you remember, it's fallen off, it's Volkswagen. So this is kind of, it detects that you're running on a CI system, and it would make all the tests pass. You can read about the reasons, like the software to be adopted by Americans, good scores need to be for the CI server. But the point is that there are evasive tactics if you want to do that, and you can't really trust stuff on there. So reproducible builds. It's been there for a while, the motto, but it's really hard. Imagine like you have a Ruby gem, and that has a license key, a license that just changes the date. Because you can, typically it's done because people don't want to change the date of the copyright all the time, and you build it again, you get a different thing. Build it again. But it could be compiler flags that are changed. It could be many things. And so it really takes a lot of energy to do reproducible builds. Debian, I think, has taken the most focus on being able to reproduce most of the builds. They're not there yet, but they've taken most of the effort to do that as well. Unluckily, Node, it's not there yet. So even the binary of Node, you run it twice on my Mac, gives a different output. So it's hard to build trust like that in a way. If you think even further, when you build yogurt, you have to have already yogurt, right? And you can keep cloning from there, but how do you get the first yogurt? And the same thing is happening actually with the Linux bootstrap process for compiling something. So this is the messy thing. Like, sometimes you see this passing GCC, phase 1, blah, blah, blah. There is still 20% in that part which is still binary and not source. And it's been cross-compiling over the years, and it can't be reproduced. So there's a couple of projects that really try to take that on. This is like a bootstrap assembler, 500 bytes or something. People are just thinking about reading from source, trying to building this up. I know this is a little segue, but I find it interesting that even that can't be reproduced from source as well. Yeah, so it fell off the top. Part of the reproducible builds, they have like this fancy tool to do like diffing of binaries. So you can see what changed. Sometimes it's a file stamp. Sometimes it's like some other changes. So they have a nice way of comparing it. But it's very similar to whatever changes to your package JSON. If you do npm update, you get like this load. Like it's like annoying. So we need to have like better tools to kind of visualize those parts because they tend to get like really long there. The funny part is a lot of people have been working about reproducible, but it's really nice for hackers. Now they can check every binary and know what it does. So this is kind of a tool that has like an Alpine Linux, which will take binaries and kind of make them scrambled again. So you can't really see what's executing. The files are scrambled, anything scrambled. So it's kind of to evade that same problem. This brings us to how do you do that in practice? I think Bazel as a build system, like one of those million, it's like the hello world of build systems again. But it's really complex. But what they're focusing on is not just building automating the build, but they are also pulling in the compiler. They're putting on other stuff. So it's like what they say, hermetic builds, in a way that, OK, I'm trying to go back, in a way that it's more reproducible, that you have like all the sources that you need, that you fetch over the network to do so. This brings us further that they're focusing on distroless Docker images because, we used to have those Docker images which were almost VMs. Then we kind of got them to minimal installs. And now they're saying, why do we need all that? We can just like compile the binary and make that into a binary Docker image. Like much smaller, much better to verify only one thing. Unfortunately, I tried it with Node.js. It's like blew up. But OK, we'll get there. And so to the extent that we finally will have almost like this software bill of material, like all the dependencies, everything's listed that we've got in our build. And in Todo even goes further that it records all the steps you did in the process. So it's not only what you used, how you do it, like the compile flags, and everything is almost like assigned through that as well. An example is Datadog, their agent, they have like completely adopted that to do their build, and also how they do their plugins updates while the agent is running. So you can kind of have like a complete verifiable build going from there. So I have to like give a shout out to that they're really thinking about making that process like that. Graphias even goes further, is if you know all the components, obviously, then it becomes easier to say, well, this is running a production. It's not secure, because now we have all the metadata information that we can reason about to decide whether that thing that is in production is not secure. Yeah, so, but it never ends. You just have to keep like monitoring, keep watching. It's not like one time, and that's why we kind of need to get better at doing this step by step. And it's not only the code that we think of. It's like infrastructure as code, data as code, like anything as code that we'll have to get better at if you want to do that stuff. And yeah. I know it's hard. Like, I haven't done all this verification, and the reason is because it takes a lot of time. But I do think as an industry, if you want to build up that trust and not just YOLO our way through the install world, I think that's what we need to work on. And the way to go is almost like building trust with a person. So transparency, we list what we did and we communicate what we did. So if everybody in this industry would start like doing that, we would have like a better way of kind of figuring out what we're using, how we're using, and how that works together. So that's my talk. Thank you for thinking with me.
My company has been working with like a deterministic build system for a couple of years, and we're starting to get rid of it actually because it ended up being like too complicated to support for a company of our size. I'm wondering if you have sort of suggestions around like how you implement these things in a way that sort of is easier to maintain, or is that like something that is a research project, or is it just not worth it right now for a company that's like 25 developers, 30 developers?
I can answer, but sir, okay.
You can answer, but you can't touch it.
No, I mean, I can't really answer. I don't have any good questions. I did this research, and I kind of wanted to get the message out, but you're right. But I didn't come across like good solutions. And I found the Let's Encrypt just inspiring because, they made a change in the way we handled the certificates, but I haven't like looked at the other parts, but maybe they know.
James, Keith, do you want to add anything? I don't know if I have a different comment.
Different comment, I guess. I think another challenge we see is that when you go to like security conferences, like one of the main targets is the build server, and like that's one of the main things that people are looking at.
Targets for hackers, you mean?
Yep.
So I know James has some expertise in this area. When people are having that problem, or what are your recommendations to them usually? I mean, how do they keep track of the stuff?
It's it's a multifaceted problem, kind of like what Patrick's talking about, and that tree kind of expands both ways. But we put a lot of trust into like this one central authority in a lot of places. So there's a lot of different layers you can put in like to add protections for that, or but I think just like being conscious of that as we're building the systems or putting the credentials in there, or how we're getting the authorization to do that, or how we're architecting. But yeah, some of the funnier security talks are like there's a talk that my friend Ken Johnson does. He calls it Dev Oops. And it's all about how you like you find the build system on the network, and then you got like you're in good shape, right? From an attacking red team or pen testing type point of view. So as on the builder side, we need to just be cognizant of that, and I think kind of learning from some of those patterns would be helpful for us. And yeah.
So I just find it security is hard, and people are easily getting fired over this. There's a lot of security incidents. We only hear about like 1% of them. That was a surprise to me. People get hacked all the time. These are systems that hold our personal information and all that stuff. And I feel like we don't talk about this enough. I know that, if I'm, again, sharing Microsoft experience, people didn't want to share the stuff we do because they feel like it's not good enough. I'm like, this is better than a lot of people are doing, and let's, learn from each other. And so it's an interesting thing where there's a lot of writing on this, but there's not a lot of solutions, and no one wants to sort of even lead this effort.
So we'll just move on then. Any successes in there? I did not know X-ray could be used as a proxy, so it doesn't even get to your system. That's pretty cool. Any other successes people want to share, things they talked about? I don't know, Keith, you've seen some stuff in London, I'm sure, but I don't know.
He's seen some things.
I've seen some things, man. I think
Keith wrote the book, Infrastructure as Code, if you don't know that.
Yeah. I think one of the things that, and it's kind of to the point of the build server as a target, is that most kind of CI and CD servers are pretty terrible about securing stuff. You could probably do a whole nother talk just about that. Even things where it tends to be, and I think one of the successes, I guess, to spin it around, is not having everybody in the organization using a single instance of the server, because it tends to be that anybody who has access and can have a script run on it can get access to all the secrets. Often, even if you have plugins, so we did an analysis on Jenkins and some of the plugins they have that will let you encrypt secrets, and it's like if you can run code, if you have access to configure build jobs, you can ask that plugin, hey, please decrypt those secrets from that other team for me, and it'll do it for you. So, yeah, be aware of that stuff, I would say.
Yeah, so in that same vein, one of the big successes I've had at my company is we moved away from an old system where we would have long-lived keys, living on the build server, to now we get very short-lived keys that are generated for a build. Then after the build is done, they go away shortly after. So that's been a huge success. So now we don't worry about, we have shared executors and all this stuff, and it's we're running code in an arbitrary code in this environment. So it's important that if these keys get leaked, they are short-lived.
I think one of the changes in mentality is also that we would think that things inside our firewall are more secure, and I think we have to leave that idea and just thinking, we need to protect it, and it's just not because it's in that VLAN that it's safe. And yeah, they tend to get friendly, so the kind of making it more like rotating new things. For example, limiting keys to a certain IP address is already quite effective, that it can only be used from there. So if somebody gets the key and takes it, it's worthless on the system. So we have to think about context while applying security as well. So.
Well, and I think that point of if you have one build system, you have Jenkins, right, or whatever, right, that's running multiple build jobs, right, you're almost better to have one build system per pipeline or app or whatever it is that you think for that workflow. And I'd say that's I know it says on this challenge up there, we were kind of saying successes. I think as an industry, one of the successes I think we're seeing right now is you see the GitHub, GitLab actually providing pretty decent security tooling inside of that pipeline, which you didn't see 3-4 years ago, right? And now that's kind of out of the box. If you're using one of those, you're now better in better shape than you would be if you kind of rolled your own Jenkins on internal property or whatever.
One other success that I've seen is partially in the education around these things, because people who really know security are pretty hard to find. And there's a gentleman, Peter Chestnut, did a talk at Debois Day, Seattle, I think last year, who talks about the job of the security people is not to secure things, it's to educate other people. So his security team doesn't actually do the things themselves. They go into the development teams, and we can talk about whether it's a good idea to have multiple teams, but they go in and their job is to educate and help people understand what these things are, and to do help them with this kind of research when they don't even know what they don't know.
So I think I shared the same success after James's talk yesterday, but I think for us, having a red team has been a huge learning experience, and it has kind of in a natural way, help people learn and understand and get more involved and care more about security. So that I would recommend that.
Yeah, I do. I do think that the idea that we can train people to write secure code is kind of a bad thing, because you can't train people to write error-free code, and so I kind of disagree on people kind of going down that route, and that's kind of been security's tack for the last 20 years, and it hasn't really worked. So I kind of prefer more to think about the model that they use at Netflix and other places. It's let's make they talk about the paved road or the regular path, but if you're using the regular stuff that everybody's using, you're going to get security quote unquote for free. And of course you still need some training, you still need some awareness of what's going on, but when you're doing these like compliance checklists or other things like that, it's like you can either implement this defensive control or put your developers through, some sort of security training mechanism. And I don't know. I feel like it's a fallacy that security has adopted many years ago, and we continue to push forward. But I would much rather see like, oh yeah, I'm using mainline, and like it already has encryption on there. Oh, it already runs all these checks for me. Like I'm already participating in security without having to do like a lot of mental, figuring it out, right?
So just to be clear, they weren't trying to teach people how to write more secure code. It was more teaching them to use those systems. Because people didn't even know it existed. It would be ridiculously easy for me to write a bad application, put our logo on it, put it on, AWS or Azure, pick your, and nobody would know it wasn't a corporate thing, because I didn't know which things to run it through.
Yeah.
So I'm going to be a little bit snarky, and what I would like to see the most in 2 to 5 years is these really talented hackers putting their skills to productive use. But that's not going to happen. So what do we need to see from our industry in the next 2 to 5 years to help us get better at this?
I think secure by default's a big one. And then another thing is not putting security features behind paywalls. So like, if I'm a small organization that can't afford, the super deluxe ultimate package, I should still be able to have like some sort of sense of security in the product itself. Like I've seen some products that actually, you can only get HTTPS through the paid version. Like that is just nuts.
That costs extra.
The other thing I'd like to see is more products. That's not even the right way to put it. Projects, because I include open source and so forth, having more sensible defaults. I mean, there's some things out there that are in wide use that if deployed and you don't know better, are wide open to the world. And I'm not going to name any names, but just in general, if we had more sensible defaults, or even less sensible defaults in the other direction, make it so they have to loosen things up if they need to. That's one thing I'd like to see happen.
I think making the right thing to do, the easy thing to do, and in contrast to the examples that Patrick was showing where it's really, really, really hard to do the right thing.
So I think one thing that was talking about the paywalls and stuff is that for the smaller companies that probably don't have as much security out there, the hackers might be using that as a test bed to see, because nobody's watching that, to see that there's 10,000 connects on something and then find a vulnerability in a piece of software and then go to the big guys because they've already figured out how to, how to circumvent it.
Anything else? Oh, sorry.
I think we're at the point where we were with CI/CD before. Like it seemed like impossible, and I think we're getting more aware of, because the faster deploys put the stress on the security people because they have to verify all the things that are changing all the time, and I think that is just like emerging in a way that we're gonna get better at it, and we're gonna get like more examples of people doing it, and then it's just gonna be inside the practice that we do that stuff. So that's what I hope. Yeah.
So that makes me, I don't want to put you on the spot if there's other security practitioners and companies too. Is people being more open part of what we need to see in the future, of what are the things that people are seeing and how did they fix it? Companies don't want to do that. They don't want to get sued. They want to pretend like they never get hacked. Is there a path to that, to sharing more information?
I mean, in the security industry, like ISOCs and stuff, like they have their own kind of way to share information across like types of threats and vulnerabilities that they're seeing inside of their verticals. Those are helpful, but yeah, you're right. I mean, like banks and stuff like that, they'd rather take the loss than the public disclosure that your money's not safe with them because of that. So, and I also think like to what was said in the opening keynote yesterday was like, kind of to like, why are we not moving at the right cadence or whatever? Like it's kind of like all the tools and the people and the process and all the stuff from the ground up is there in most organizations. I feel like we're that way with security too. Like it's sort of like, are the executive layer buying in? Are we implementing this stuff? And like, is security scapegoated? Much like CIOs kind of get like seen as a cost center kind of that chart that they had set up. And I feel like security's a lot in the same way, right? And like the CISOs kind of get treated in the same way. And so we'll see the organizations that kind of put, I can't remember that last column, but high performing or whatever, right? It's like
It was when the CIO reports to the CEO.
yeah, right. Where the CISO is like has a seat at that table or is performing, and then like they see it as a value piece, and like security isn't different from IT or isn't different from the rest of the business. It's just like part of it, and so hopefully that'll change. But I think that takes time.
So as a productive hacker, I'd like to say that part of it is there has to be an acceptance of that natural friction that comes with security, right? As a security practitioner, I understand that when I go to a developer and say you need to fix this bug, I'm asking them to put something in their backlog and add to it. But part of that change needs to be a developer accepting security as a partner in that and saying, all right, they're not coming to me to add to my backlog, they're coming to me so we can together can put out a better product. So part of what needs to change in the next 2 to 5 years is that sort of embracing of a partnership, because there's absolutely no way to do frictionless security where I'm not putting more workload on a developer.
So this is the same thing with technical debt and improving ways of working. It's non-functional improvements that are important and necessary to be made, but they get put in the backlog and they compete with revenue-generating work. And so I think the real question is, how do we make the business, the people who are prioritizing the items in the backlog, aware of this necessary change to reduce risk and debt?
So, a part of that conversation has to be you going out and finding out that information, right? So if I look at the information that we hold in our company, I go out and I find out what that's worth on the black market. I go out and find out what that's worth in fines. So if someone gets hit with a fine for a data type that we store, I need to be able to say, you know what, we store 1 million of these, they're worth $350 a piece in fines. You do the math and what you save us. Part of that is as a practitioner gaining that knowledge and making sure I'm informed and not speaking in generalities.
So just want, like, my favorite metaphor for security is, like, so think about us building a mansion. So I'm building a mansion and bringing in the best, like, TVs and the best, like, I don't know, furniture and everything. And the one thing I'm not doing is putting a lock on the door. Right, and every time we're going through this, I'm like, yeah, but I'll do it next week. Like, we'll get to it before, and then it always gets pushed out, and then like eventually we don't do it, and then like, oh my God, we just got completely robbed, and all these like hundreds of thousands of dollars just went away. Like, a surprise. So just kind of like maybe having visual metaphors or like putting dollar signs to it, I don't know, but just kind of making people understand that this is not an afterthought. This is something that we need to start with.
Well, and one thing, yes, sorry, Dominica, but one thing on that, exactly that metaphor, but it's security doesn't, we haven't like exposed the fact that like you would put locks on your door if like day 2 of living there, you kept hearing someone kind of jingle all the handles or like try to pry open the windows. But that is obscured and obfuscated from business decision makers, and so they don't know like that stuff's being attempted. They don't know what's actually happening. So there's that lack of feedback loop, which I'm guessing Dominica might say something like that, because I feel like you hit the nail right on the head, like for why that's the problem.
And Dominica's going to have the last word because we're kind of at time.
Well, rightfully so. So what you just described is a way to bring visibility to the cost of delay, of not prioritizing that important work. Just yesterday we were talking about how to get buy-in from executives, how do we help them get the approvals to make the change we need, and somebody brought up ROI. And so what you just described was a very valid way to do so, and I've never thought about it from a security perspective. Thank you so much.
Thanks, everybody. Thanks again, Patrick.
Joseph?